Hello, so in this video, we're going to look at sketching graphs in the form y equals a over x squared. So the last video, we looked at sketching 1 over x, 2 over x, 3 over x, those kind of graphs. In this video, we're going to look at sketching 1 over x squared, 2 over x squared, and so on and so on. So these graphs will look something like this. You can use like a graphing software to check this out, or you can just use some substitution, just plug in some x values, plug in some numbers into this formula, and you get a shape that looks like this. So basically, yeah, if we just call this the graph y equals 1 over x squared, for example, when we plug in x is 1, for example, we get 1 over 1 squared, which is just 1. So that would be 1 up there. So yeah, we get kind of this kind of shape here. So when x is 2, for example, you should get a quarter because 2 squared is 4, 1 over 4 is 1 over 4. So yeah, that should be a quarter really there. And the same kind of thing on the negative end as well. So this time the graph will not go below the x-axis, and that's because when you square a negative number, you get a positive number. So squaring -1, for example, gives you 1. 1 over 1, well, that's just positive 1. Well, I mean, again, it's not a very good graph, but essentially, yeah, this should match up with that there, essentially. And then the same thing with the -2. This should give you 1 quarter, because -2 squared is 4. 1 over 4 is 1 over 4. Okay, yes, that's the graph for this graph, 1 over x squared. And yeah, as we talked about in the previous video, so when you increase the numerator, you're just going to increase the y coordinates. You're just going to, in this case, with the red one, double the y coordinate, or you're going to treble it with the blue one, just because you're multiplying your y coordinates by the constant in the numerator there. So yeah, that's the kind of shapes. These are the kind of shapes you'll be getting with these graphs here. And as we mentioned in the previous video, we had these things called asymptotes, so lines in which the function is undefined. So yeah, so where would this function be undefined for this? Let's just say this 1 over x function, for example. So this 1 over x 1 over x squared, I should say. So yeah, this graph, this function is not going to be defined when x equals 0, because otherwise when you do 1 divided by 0 squared, that's 1 divided by 0, that's not defined. So we've got an asymptote at x equals 0. Let's just make a point of this. So when x equals 0, so in other words, the y-axis, so this is one of our asymptotes. So we're just drawing a dashed line to represent the asymptote. So asymptote at x equals 0. And then we've also got another one at y equals 0, because if we rearrange this graph, this equation, we get x squared equals 1 over y. Well, if y is 0, then x squared is not defined. So in other words, x is not defined. So again, we've got another asymptote at this point over here. So on this line here, sorry. So yeah, when y is 0, so asymptote when y is equal to 0. So yeah, again, we get two asymptotes for this 1 over x squared graph. And it's the same story with the 2 over x squared, 3 over x squared graph, half over x squared. It's always the same story. However, I will mention this: if you actually had like a negative sign here, so like a minus sign, just be aware that the new graph of this would be this instead. So this would be the graph y equals -1 over x squared. And again, it's the same picture. So you're going to have an asymptote when y is 0 and also x is 0, because again, when you substitute in x equals 0, you get an undefined fraction. And when you rearrange for x squared, again, substitute y equals 0, -1 over 0, you get an undefined x squared and an x value. So yeah, so that's how you would sketch these type of graphs. These graphs in the form yeah, y equals a over x squared, where a is just a real number. And again, the key point is that if a is negative, just be aware that for negative a values, it would be a graph like this, and for positive a values, it would be in this positive shape like that there.